Okay, this is lab number 1 in fields that we're going to work on. So we have two devices here. This is signal generator, and this one is spectrum analyzer. So this one is generating signal, as you can see, and this one can show the tones of signal, the power and the frequency. So what do we have here? What do we have here? We have the frequency, we have the amplitude, the power we are applying, and so we have a control here when this is gray level, so that means it's deactivated. This is not active now. That means the power that is coming from here, this is the RF output 50 ohm, everything or standard here in this lab is 50 ohm. So this is the output of the signal generator. When you activate this RF on, you see this turns on, and when you deactivate, you click again. So right now it's not sending any signal here, but before it was. And this is 50 ohm cable. We have Agilent cable to foot. It's connected to the input of this spectrum analyzer that is from 9 kilohertz to 3 gigahertz. Okay, so what we have here, we need to able to change the frequency. You just click on frequency here, and then you change the frequency to what you want. So the maximum frequency of this signal generator, as you see here, is 3 gigahertz, and the minimum is 250 kilohertz. We need to be in this range. Okay, let's say like I want to see 1 gigahertz. So you push frequency, and then you push the frequency you want to, and then you see some tabs here. You click what's the unit, and it will have 2 gigahertz. The next step is you want to change the amplitude of this. So you click on amplitude here, and you apply how much power you want to apply. So we say, for example, 0 dBm, or we want to apply, for example, minus 5 dBm. You see that? Okay. So what is this dBm? You know the frequency, that's the unit. So this is a unit when we want to work with power. When we go to very low power, for example, milliwatt or less than that. So to be more reasonable, and we can have a better understanding, the feeling when we are talking about the power, we use dBm unit instead of watt. So these two, they can be converted to each other, dBm and watt. It's very simple. You just need to come to Google here and say, for example, there are calculators. Let's say watt to dBm. You just type in Google, and then you pick, for example, this calculator here, and then you can convert these two into power in dBm. For example, how much is minus 10 dBm convert to watt? It's 0.0001 watt. So and this is the equation it's using, and to have a better feeling, 0 dBm is 0.001 watt, and you can find other ranges. Okay, but we are going to work in this lab with dBm unit, and later if you work in microwave field, you will see this is a more common unit we use. Okay, so we are going to adjust the power, the amplitude to minus 10. Never ever in this lab go more than 0 dBm, that it can hurt this spectrum analyzer. Okay, so minus 10 dBm we apply here. And what frequency? We want to work at 1.25 megahertz, so we apply 1.25 point. Sorry, I didn't push frequency here, so I push frequency first, and then I apply 1.25 megahertz. Okay, and it's not applying the signal yet. Okay, now I want to apply the signal with pushing RF on, and the signal generator is applying the signal here. Do we see anything here? No. Why? Because the signal we are applying is at 1.25 megahertz, but our span here is from we have from 0 to 3 gigahertz. So that's why we can't see it anything here. Almost the signal is here. Okay, so we need to adjust the center frequency. Right now center frequency is 1.5 gigahertz to this frequency that we have here. Okay, so we click on frequency first, then it shows some tabs here. We click on center frequency, and then we click on 1.25 megahertz. Okay, here is our signal, as you see. Okay, I want to put a marker here to see how much this value is. Okay, so I click on marker, and there you go, that's the marker. And you can adjust the frequency of marker 1.25 megahertz. It's minus 9.5 dBm. Here we are applying minus 10 dBm. We will have loss, and also we need to increase the resolution bandwidth to be able to see a better value here, more accurate results. Okay, so as I said, right now we have the resolution bandwidth of 1 megahertz, and we have a span of 162.5 megahertz. We need to change both of them one after each other. Okay, let's change the resolution bandwidth. Right now it's 1 megahertz. Okay, so what does that mean? That means the signal that's being applied to this, there's a filter here that 1 megahertz by 1 megahertz is trying to apply a filter and window the signal and show it here. So we want to increase our accuracy. That means we need to reduce resolution bandwidth here. Instead of 1 megahertz, let's have a filter 1 kilohertz by 1 kilohertz is sweeping, and it's we will see the results here. Okay, so to do that, we need to change the resolution bandwidth. We click on this BW average, then we see here resolution bandwidth. As you see, you click on that, and then you adjust it to 1 kilohertz. Definitely it would take longer to see the sweep here, because before it was doing it 1 meg by 1 meg and very quick. Now it's doing 1 kilohertz by 1 kilohertz, and it takes longer. We need to wait for it. So what do we expect? We expect to see when we are increasing the accuracy, so we need to see a more accurate value on our screen, something closer to minus 10 there, and narrower band, which makes sense because we are reducing our resolution bandwidth. Okay, we will wait till one sweep completely is done. The next step is changing our span after the resolution. Okay, one sweep is done completely, and this is our resolution bandwidth, 1 kilohertz, and see the noise level is lower now. The signal is pretty close to 10 dBm, what we expected, and we see our bandwidth is narrower. Okay, still our span is pretty wide. I want to decrease this window. Right now it's showing biggest span. I want to decrease it. So let's do that. Let's click on span here, as we see, and then right now it's 162.5 megahertz. We put this span in at 50 megahertz, 50 kilohertz. Okay, so 50 kilohertz. Here's what we have now. It's almost minus 10 dBm, and this is what we have. So what we can do here, you see a little bit signal, it's a little bit lower than the minimum what's in the screen. So we can shift this up a little bit to have all of these low values in our window. Okay, so to do that, we click on amplitude, and then we change the reference level. Right now it's at 0 dBm. I want to shift the signal up a little bit. So with this knob, I can change it a little bit up. Here we go. Now most of the signal is here, right? Okay, and look at this value. It's minus 10 point something now. Our reference is minus 7 dBm. So it can be here, or it can go lower based on what we want to be 0. Here we go. Okay. So what's the next step? The next step is I want to see 50 dB bandwidth. That means I need to put one marker here, 50 dB lower than max, and another marker here, 50 dB lower than this max. Okay, so we click on marker again. Okay, and then right now this is marker number 1. We click one more time, select marker. You see number 2, there is an underline. And then when you see that, when you see marker number 2, there's an underline. So you select first marker, then select marker, then normal, and then number 2 is there. You just need to use the knob to change it. Okay, so it was at minus 10 almost. You want to see 50 dB bandwidth, so you need to go 50 dB down. That means it needs to be adjusted at minus 60, right? It's almost minus 60. Okay, the next one, we need another one at high frequency. So the same thing, we go marker, select marker here, number 3, and then we click normal. So we use this knob here, and we go to minus 60, almost here. Okay, this is 50 dB bandwidth of our signal. And then now what we can do, we can show it on a table, actually, all the markers. So we click on marker, and then click on more here, and then we click on marker table on. So there is a table here, marker number 2, 3, the frequency of the markers and the amplitude. So as you see, there is a bandwidth almost it's almost 10 kilohertz bandwidth of this one tone sinusoidal wave. So basically in ideal it needs to be 0, right? But it's not, it's 10 kilohertz. Okay, the last step here is we want to see harmonics of a sinusoidal wave. Okay, because our signal generator is generating a sinusoidal wave. So how to do that? We need to just to go to higher harmonics. That means when we have 1.25, we have the second harmonic at 2.5. We want to see the second and the third harmonic. So we adjusted from 1 meg to 4 megahertz. So frequency here, start frequency 1 megahertz and stop frequency 4 megahertz, and we wait for the sip. Okay, so we adjust the markers at the right position, so we click on marker here. Okay, then we go select marker number 1. When underline is under marker 1, then we try to use the knob and we put marker number 1 at the center frequency of our band. We try to adjust it at 1.25. Actually, we can put this value 1.25 megahertz. Okay, it's adjusted marker number 1. Then select marker, we pick marker number 2, and we know what the frequency is. It's here. It's at 2.5 megahertz, right? So we put 2.5 megahertz, and that's number 2. And number 3, so the same, select marker number 3, and then we put 1.25 multiply by 3, so it will be 3.75, right? So we put 3.75 megahertz, and this is the second harmonic, the second harmonic, the third harmonic, and this is the fundamental, and these are the amplitude. So we need when we have a circuit or an active circuit, it will have harmonics. This is a very good signal generator that higher harmonics to a very low in comparison with the fundamental. It's almost minus 50 dB down to second and the third. So this is the last part. We take a photo, screenshot, and that's it. Okay, so this is the last step you work on. This is one of the antennas that can receive on low frequency FM signals. So you connect the antenna through this cable to the spectrum analyzer, and then you adjust the band of frequency from 87 megahertz to 108.5 megahertz. This is FM channel, and then you will see some tones. Each of them, they are a channel that you can listen to radio to them, and you can adjust the markers. Well, I would just you can adjust. I want to turn off number 3 and also number 2. I just want to have number 1 on. Okay, and then marker. So this is number 4. Turn it on. Number 1. Okay, this is my number 1, and you can adjust it at any frequency. For example, here to read the power, and also the frequency. Also, you can zoom in. For example, let's say I want to see this better. This frequency, it's 97. I listen to 102. Let's see if I can find it. It's very low. Okay, let's zoom into this. 101.15. Okay.